All right, we're going to wrap up the quadratic formula today and uh, go over the next section, which is going to be 6.5, the discriminant. We're going to talk about how the discriminant connects with the quadratic formula. It's very simple. This is a very short section, and we'll wrap that up here in just a minute. Let's go over this page here, 6.4, 267. We're going to solve the following quadratic equation in the using the quadratic formula. It's easy as it can possibly be. All you have to do is move things over from one side to the other to organize them. So we're going to combine like terms here by moving that 2x over and making it, it's going to become negative 2x on the other side. And that negative 9 or minus 9 is going to become positive 9 on this side over here. Okay. Now we've got to combine like terms, and we've got negative 12x plus 9 equals 0. So these are the a, b, and c values that we're going to use to fill in the quadratic equation for negative 12 and 9. That's what we're going to use. And the way the saying goes is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, like that, okay? And then you fill in the blank from there. So we're going to substitute the values of a, b, and c into the formula. So we've got x equals negative blank plus or minus the square root of blank square minus 4 blank blank all over 2 blank. And a shows up twice here and here. So I'm going to put 4 here and here. I'm going to put b. It shows up twice here and here. B is negative 12. With the change pins. That one's kind of... Okay, so and then c only shows up once in the formula. C is 9. So we're going to put 9 right there. Now we're going to simplify it out. So this double negative becomes positive. Negative 12 squared is going to be 144, and then this is 16 times 9 would be 90 plus 54 would be 144 also, I believe. Let's see, double check that. Yeah, 144 also. So there's the, okay, so 16 times 9 is 144, so that turns out to be 0. That's kind of interesting. And so, oops, I'm going too fast. Okay, and then 2 times 4 is 8. So we're going to rewrite this out as obviously 144 minus 144 is going to be 0. So this is going to turn out to be 12 over 8. It's only one answer, one solution. There's no plus or minus here because if you add 0 or subtract 0, it doesn't change it. So we're going to simplify the solution, and it's going to be divided by 2 is 6 over 4, and then divided by 2 again is 3 over 2. So my solution is x equals 3 over 2. And the number of solutions is 1, and it's real, okay? So I'm going to pull that back so you can see that and let you get a couple of seconds to write down with me what you're doing. All right, so so far what's happened here is we took a quadratic equation where we had something on the right-hand side that we needed to move over and set it equal to 0. We had to find what the a value, the b value, and the c value was, throw it into the quadratic formula, which you need to memorize this, and then fill in the blanks with your 2 b's, your 2 a's, and your 1 c. And then you come down here and simplify, and it worked out that we only had one solution. So what does it look like? If you were to graph this, it's possible that it would have had a solution. I don't know where. I mean, yeah, well, I do know where. It's over here, right here where 3 over 2 is, okay? So, all right, I had just had a person, somebody come in and join the Zoom. I've already started the first page. I'm zooming through this because I'm trying to get to this next section. which is 6.5. And I'm shooting for Wednesday review. We're going to review, well, the second half of Tuesday or first part of Wednesday. We'll review section 6 or chapter 6 or whatever. And it's okay if you didn't write this down. I'm going to go start a new problem here in just a second. And if you type it in the chat, if you have any questions, I can go back to this at the end and then give y'all time to write this right here. I just wanted to show you how solve this out, okay? All right, let's go do the next one real quick. If you have 6.4, 268 is the page here. We're going to solve this quadratic equation using the quadratic formula. All right, let's practice writing the formula down again. It's okay, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, just like that. And this is the formula you're going to use. A, b, and c are here. They're already, this one's easier than the last one because my a is already there, my b is already there, my c is already there. It's set equal to 0. So all I have to do is throw in the values for a, b, and c. A, b, c. So a x squared plus bx plus c, that's the standard form of a quadratic formula. So we just wrote the quadratic formula. Now we're going to substitute in the values. So we're going to put x equals negative blank plus or minus the square root of blank square minus 4 blank blank all over 2 blank. And now we're going to fill in the blanks with a, b, and c. All right, a happens twice. A is 1, so it happens here and here. We're going to put 1 and 1, just like that. B happens twice. It's negative 6, so I'm going to put negative 6 here and here. All right, and C happens once, so I'm going to put it way over here to the far right. And then let's rewrite this out. Now we're going to simplify this, okay? So x equals positive 6 plus or minus the square root of 36 minus 40 all over 2. Now I'm going to tell you right now, we can go ahead and stop everything we're doing and circle the word complex, because the type of solutions we're fixing to get are complex, because what's under the radical is going to be a negative number. And anytime you have a negative number under the radical, you're going to have I involved, imaginary numbers involved. So there's going to be 2 solutions, but they're going to be complex. All right. Now let's go down here and work this out. It's the square root of negative 4, right? So because those subtract out to be negative 4. And here we go, x equals 6 plus or minus, now this is going to be 2i over 2. And we reduce that down into, now remember, cover this side up. So that's 6 over 2, which is 3. And 2 over 2 is 1. So my answer is, now keep in mind it's plus or minus I here. Now how did I get 2i here? Because the square root of negative 4 is the same thing as the square root of negative 1 times the square root of 4. And the square root of negative 1 is I, and square root of 4 is 2. So that's where the 2i comes from there. All right. So when I rewrite my solution, there's 2 solutions. One where x is equal to 3 plus I, and the other one where x is equal to 3 minus I. All right. So there's my 2 solutions there. All right. And they're complex. And I think we're pretty much through with that one. Let's go ahead and pull back and give you a second to kind of catch up with me. I know I'm zipping through super fast on this, but it's the more you practice this material, it's basically cookie cutter, straightforward. And remember, like I said last time, you you can use the quadratic formula for every single quadratic equation. You can always do this. This amount of work is always doable. Sometimes you can get the answers much quicker, and you got to be smart about what you use, like the completing the square, or factoring. Sometimes factoring is easier, and you can just do everything in one step and cover up all this mess and get to the answer really quickly. But in this case, it wasn't easy because, for one, this was not factorable. You could not factor it into x times x, and then 2 times 5. 2 and 5 do not make 6 when you add them together, right? You can't. There's no way you can work that out. Not factorable. So you have to use the quadratic formula for that, okay? All right, so now we're going to, this is what we're going to review on Tuesday or Wednesday. I'm going to go and print off where it says homework 6.3. Well, I may change my mind. Hang on to that. I'll write down a note if you're having a question. There's a review section. I think I'm going to scrap this homework section and then go to the review section for Tuesday and Wednesday. I changed my mind, okay? All right, we're going to go to 6.5. And now 6.5, if you print off the little thing, I think it's pages 33 through 36. That's what we need to make sure you print off. And I sent a link on Microsoft Teams if you wanted to print that PDF file of what we're doing right now. We're talking about the discriminant. And you're going to see something similar here to what we've just talked about. All right. The reason we talked about the quadratic formula earlier, this right here, is because it leads into this word, the discriminant. And we'll get to that in just a second. Let's read through some of the steps and kind of lead up to it. And I want to try and finish 6.5 today if possible. And there are about 3 pages, and then we're going to see what happens here, okay? So today we will continue with the quadratic formula. When graphing a parabola, this thing right here, when you graph a parabola that looks like that, and you got ax squared plus bx plus c, we know how to find the vertex. The vertex is down there, or it could be upside down and above. The axis of symmetry is on the vertex, right? And then you determine the direction of the opening and the plot of the graph. So that's how we graph that stuff. And then when solving ax squared plus bx plus c equals 0, we are setting y equal to 0. That's this right here. So if you type this in the calculator, you'd push the y equals button on your TI-84 and then type that in. And then solving for x, for finding the roots or x-intercepts. The x-intercepts or the roots are right here, where I'm putting these arrows here. All right, and so what are the possibilities when solving ax squared plus bx plus c equals 0? Well, we'll get to that. Well, let's go over some possibilities. Okay, remember, there's always the possibility of 2 solutions, 1 solution, or 0 solutions. And in this case, it would be 2 complex solutions. All right. So 2 solutions would be something like this. All right. Hey. And then 1 solution would look like this. Okay, 0 solutions would be where it does not touch the x-axis at all. So in other words, there's no real solution there. So we have 2 real solutions here and here, 1 real solution there, and no solutions here. Okay. All right. So in the quadratic formula, we've got x squared, or x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So you need to memorize that and use that on the ACT a lot. It helps you get through a lot of the ACT without having to worry. The discriminant is the term. Now let's talk about what this is. The discriminant is the term b squared minus 4ac. It's the part under the radical. I'm going to go ahead and circle that. You can too. So b squared minus 4ac is the discriminant, and it's the thing you add or subtract to the b term here. In other words, it's like here's the axis of symmetry. What do you add or what do you subtract in order to get to the roots? Okay, kind of like that. So when we determine the type and number of solutions yielded by the quadratic formula. All right, so in other words, you can use the discriminant to determine how many roots there are going to be. Okay, you remember a while ago I had 144 minus 144 like that, and it was equal to 0. Well, then I said, oh, well, you can go ahead and just say I have one real root, right? One real solution, because you're not going to add or subtract 0 to something. You're just going to leave it as is, and then you're going to have, in other words, you have this value, and you're not adding or subtracting anything to get to the other two roots, okay? So if it turns out that the discriminant is 0, you have one real root, okay? The discriminant is this, the b squared minus 4ac. That's what that was, okay? B squared minus 4ac, right? So if the discriminant was less than 0, you're going to have two complex roots. And if the discriminant is greater than 0, you're going to have these two kinds of things here, okay? Either rational or irrational. In other words, the solutions could land directly on a line, right on a unit, or it could land somewhere in the middle, which is a fraction. So that's irrational. So in other words, I always say fractional, irrational. That's the way I think of. I mean, I'm sorry. Yeah. Yeah, I can't think this morning. I got so much going on. I'll go over the other stuff. Okay, so my bad. So let's keep going here and kind of discuss what we're doing with the next page. So we got 6.5, 273. That's the page that we're on. I believe it's page 34. I'm not sure if you print it off on that 6.5 section here. All right, so we're going to consider this right here. This is not factorable. I mean, you could sit there and all day long and try to figure out what the factors of this are, right? And you're going to find out that now, okay, in this case, it looks like it could be factorable because you got 2 and 3 times are equal to 6 when you multiply them, and then when you have 3 and then you take away, or you have 2 and then you take away 3, like that, you have a -1 value. You see that? These actually are factorable, and so the answer. Let me show you real quick how you would do this if you were using factoring. So you remember how you take the opposite of this sign right here and put 2/1. So your one solution will be -2/1, and the other solution would be +3/1. So that's the fact. See how quick that was? If you memorize this stuff and you know what you're doing, when you try to solve or by factoring, the answer should be -2 and +3. Well, let's come down here and talk about how to do that using the discriminant. Let's go find the value of the discriminant. So let's write down 4ac like that. Let's say, for instance, you didn't have time to sit there and think, oh, is that the formula? Is that the factorable? Let's use the quadratic formula. If you're crunched for time, you can always go to this. All right, so let's talk about what A, B, and C are. A is 1, B is -1, and C is -6. So we're going to fill these values in. So we've got A, B, and C here. I always put blanks like this to help me clarify what goes where. And so we've got -1 squared, which is 1. And then this is a +24. So this 25 is a perfect square. Check that out. This is a perfect square. So let's go back to the chart here. So if you were to square root b squared minus 4ac, right? If you were going to square root 25, you'd get ±5, right? So let's look at this. So the answer the discriminant is a perfect square. It's greater than 0. So you're going to have two rational roots. Irrational is like square root of 2 or square root of 7 or pi or something like that. That's what irrationals are. Rationals are fractional. So you can think of it like 3/4 or something neat and easy to deal with. Okay. So we are going to be rational. In other words, the answer is going to be a fraction form. Remember, we just solved it out really quickly using factoring. The answer is going to be -2 and +3. We'll discuss that in a second. All right, so the number of solutions are 2, and the type of solutions are going to be rational and real. All right, those are the 2 words that you need to remember. So we're going to find the solutions now. So how will we do that? So x equals -b plus or minus the square root of b squared minus 4ac all over 2a, just like that, and fill in the blanks. Remember to fill in the blanks. All right, 4ac all over 2a. And so we're going to fill in the 2a's here, which are 1, the 2b's here, which are -1, and then the c was -6. So we found out that the discriminant was the square root of 25 or 5, right? So the answer is going to turn out to be 1 plus or minus 5 over 2, or in other words, it's going to be 1/2 plus or minus 5 over 2. So let's see what happens here. So what happens if x is equal to 1 plus 5 over 2? Well, that's 6 over 2 or 3. Does that sound familiar? We found that a while ago up here, okay? You know, see how much work it went in to get that answer right there, and all you had to do was 2 steps. Well, that's if you know what know which tool to use, okay? So we've got x equals 1 minus 5 over 2. So that's going to be -4 over 2, and x equals -2. And so there's my final answer. My 2 solutions are 3 and -2, just like we found out here. 3 and -2, just like that, okay? I know I went really super fast on that, but I'm trying to show you how to attack these kinds of problems whenever you're working on the ACT and you don't have it 1 minute to do it. Well, if I didn't have it 1 minute to do an ACT problem and all I had to do was find the roots or the solutions to this, I would go here and scrap that and give myself plenty of time. But sometimes you can't. Sometimes, like I said, you can't factor these things. And trust me, on the ACT, they're going to give you something that you can't factor, because they are looking to keep you from making the highest score possible, because guess what? They will pay you money if you make the highest score possible. All right, so let's go find the discriminant value here. And they don't want to give every single person a full ride to college, because that would not be very profitable for them. A, B, and C. So we've got A is 1, B is -1, and C is -1/4. All right, the number of solutions are, let's see what that would be. So we're going to put -1 squared minus 4 times 1 times -1/4. All right, we got a kind of a tough looking discriminant going on here. So this can be 1 plus, what's 4 divided by 4? That's 1. So the answer is 2. The discriminant is 2. So if that's, notice that 2 is not a perfect square. So if you were to square root b squared minus 4ac, all right, what you would get is the square root of 2, and that's irrational, okay? That's something you can't make a fraction out of. So the number of solutions are going to be 2, obviously, but you're going to be this time irrational and real. Every number is real. Every number you can think of is real. Even, to be honest, I feel like even complex numbers are real, okay? We discussed that a couple of weeks ago. So we're going to find the solution to x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Well, we can be smart about this and fill in our b and our 2a down here just like this. Our b was -1 and our a was 1. But remember, we already did this part right here. So it's plus or minus the square root of 2, right? So we did all the work up here. So it's b squared minus 4ac equals 2, right? So that goes under here. And we're going to rewrite this. It's going to be 1 plus or minus the square root of 2 over 2. So if you were to take a second and look at this, it's going to be 1/2 plus or minus the square root of 2 over 2. All right. So, and the way I would write it, the way I would actually leave it in this format. Okay. So, but they want the two solutions. So let's go ahead and work it out. One solution is going to look like this, and the other solution is going to look like this. This is how I would actually leave the answer at the end, okay? Now, we may wind up ending a little sooner than I expected. The reason we're zipping through this so fast is I want you to get to the point where you're like memorizing where things go, and you need to get to the point where you can do this within a minute, okay? It's just like with any skill, you want to try and get as fast as you possibly can with it once you get to the point where you can do it. If what time is money, right? So you want to make as much as you possibly can physically without going, without taking too much time. All right, so we've got b squared minus 4a squared ac is the discriminant. So we're going to fill in the blank again with b, a, and c. A is 1, b is 14, and c is 49. So those are some big numbers there. I wonder if that's factorable. Let's see if it's factorable. Yep, it is. And so guess what? There's only going to be one solution, because if you take the opposite of this sign, it's going to be negative 7 over 1. And this is also going to be negative 7 over 1. There's going to be one solution. And the type of solution is it's going to be a rational. It's going to be real, and the answer is going to be negative 7 down here. In other words, this graph is going to cross at negative 7. So see how fast that was done, right? But wait a second, we need to go back and learn how to do the discriminant stuff. So we're going to put b squared minus 4 times 1 times 49. This is a lot of mental work right here. So 14 squared is 196. All right, so we're going to put 196, and then we're going to put 4 times 49 is 196 also. So check that out. So notice that both of these are the same. That equals 0. So that means we're going to have one solution according to this chart right here. The discriminant equals 0. So we're going to have one rational root. All right. So we do have one rational root, and that's it. That crosses right there, and we're done. Now let's talk about how to find that actual root using the quadratic formula instead of factoring like I did up here. All right, negative b plus or minus the square root of b squared minus 4ac all over 2a. I think the best thing for you to do is to always try the factoring part first. And then if factoring doesn't work, if you're really good with completing the square, then try completing the square and see if you can answer it. But if you're not really good with completing the square, it's okay. This turns out, I'm just going to shorten this up. This turns out to be equivalent to negative 7. I'm going to clean this. See how it's got negative 14 over 2 right there? What's negative 14 over 2? Negative 7, right? Negative 14 over 2. Now, it's plus or minus the square root of 0, right? Because this right here turned out to be 0 because 196 minus 196 equals 0. And so all of that mess turns out to be one rational root. I'll leave it there for a second to let you catch up, and then we'll finish up this last problem. Yeah, we got one more problem, and I'm going to shut off early today, okay? And since I'm shutting off early, I'm going to go back to that first page that some of y'all missed. and give you all a chance to rewrite that first page that we did today. Oh, and by the way, when you're watching YouTube, if I'm going too fast, slow me down. There's a little button that'll slow me down. I'll do this off to the side. If I'm going too slow, speed me up, double time. Get this thing over with, right? Let's see. Let's go down here to this last problem. I wonder if this is factorable first. So let's go and work this out. Get in the habit of learning how to factor stuff. Notice how 2 times 1 is 2. And I'm noticing right here that -1 is a possibility. If I put a minus in front of that 2 and a plus here, does it work out? Actually, it doesn't. This is not factorable, because if you'll notice here, your inner term is -2 and your outer term is 1. That makes -1, or -1. Well, when you multiply these together, we get -2, and that's not going to work out. So factoring doesn't work. So that's why this is going to have to be a possibility. Now you could do completing the square where you move the 2 over and then you cut -1 in half and square it and add to both sides. You could work on that. I mean, we've got a few minutes, a few seconds. Let's try that. Let's do completing the square in this little box. Okay. So I'm going to show you how completing the square would work. So I moved the +2 over to make it -2, and we cut 1 in half, and then you square it. So you cut 1 in half, and then you square it. So now we've got a perfect square here. What's the perfect square? It's x, I believe it's going to be, since that's going to turn out to be a positive, this is going to be a minus. Okay, negative. Okay, so -1/2. Okay, so it looks like that. So if you notice that this term right here and this term are the same, that's because if you multiply this by itself, if you square this, that it turns out to be look like that. But since this term is 1, yeah, you would have to factor out that 1 first. See how much more thought process goes into this? It's a little bit more difficult than so now you could factor this out by square rooting both sides, right? And then you get plus or minus there, and it's a lot of work, right? So that's just a lot of stuff going on there. Let's not do completing the square. That's kind of so that's why using the quadratic formula is a lot better, because you can always do it without having to guess what's going on, or you won't make a mistake. I'll just put it that way, as easily. So let's see what this is. Is this a perfect square? Is this not a perfect square? So that's going to be, I forgot to square that. So that's going to be 1 minus 8. 1 minus 8 is -7. That is going to be not a perfect square, so that's going to be irrational and real. The solutions are going to be irrational and real. There's going to be 2 solutions because we're going to add or subtract. Remember how it's the square plus or minus the square root of b squared minus 4ac? You're going to add or subtract the square root of 7. And so that's why it's irrational, because you can't really do anything with square root of 7 to make it a fraction. All right, here we go with our last solution. So it's going to be x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And so x equals negative blank plus or minus the square root of blank squared minus 4 blank blank all over 2 blank. And then your b term is -1. Your a term is 1, and your c term is 2. And so we've already figured out the discriminant was -7. So it's going to be 1 plus or minus the square root of 7 over 2. And so my final answer is x equals 1 plus square root of 7 over 2 and 1 minus square root of 7 over 2. Okay, there's my 2 crazy answers that are irrational. And that's what I would have wound up with if I'd have worked this mess out right here, all this crud right here, right? So I'm going to take a second and go back to that first page we still got about 5 minutes left. The first page that you guys missed today, I'm going to make sure I go back to that and let y'all write there. Okay, so let's pull this back. All right, this is the first page that I did today. Before a lot of y'all, some of y'all joined earlier. I'm going to leave that up, and then we'll discuss this. This was the one where we talked about the discriminant underneath the radical. It turned out to be 0, and when the discriminant is 0, you get one real solution, and it could be either rational or irrational. In this case, it happened to be rational. But why is that? Why is it rational? Because 0, it can be argued as a perfect square. I know it sounds funny, like, in other words, a little dot like that has 0 area. Can you make a square out of a 0 area? I don't know. I mean, who's to say? I mean, it's like, what shapes can an atom take on? Can an atom change its form? Can an atom look like this, or an amoeba looking shape like that? I mean, what can an atom look like? If it doesn't exist, it could look like anything. So you might as well consider it looking like a square. So now let's go over here and look at the A, B, and C term. If you'll notice, these were not nice and pretty in A, B, C form. So we had to move things over. The -2, we moved it over. Sorry, +2, we moved it over and made it -2. And then -9, we moved it over and made it +9. So solved it out. We got 12x here. And then filled in our blanks with the formula. Here's our blanks. You got B twice, you got A twice, and C once. 12 squared is 144. 9 times 4 times 4 is 144. A square root of 0 you don't have to worry about adding 0. It's 12 over 8, which reduces down to 3 over 2. That's one real solution, okay? And the way it would look would be like that. One real solution. In other words, on the x line, where's the root of this graph? It hits one time right there on 3 over 2, okay? All right, so I'm going to leave today, and we'll come back and do geometry in just a little bit and finish up today. Are there any questions before we leave? Just type them in the chat. All right, we're going to end it today. We'll see you later.